Live. Good evening, bachcho. How are you all? I hope I am clearly audible and visible to everyone. Everyone, please be active on the chat box and let me know my voice is crystal clear or not. Everything is fine. Chalo. So, we are talking about this beautiful series where we are discussing complete theory of machine as well as vibration. And theory of machine ka a bigger part we have already completed. In the last session, I was discussing about balancing, and somehow I have seen that in some cases, like if we are having rotating masses, so at least we can think of that rotating masses can be balanced. Maybe some practical reasons ki wajah se, due to some practical reasons, I was not able to completely balance even the rotating masses. Why? Because some manufacturing restrictions, you have balanced it, and still if you are having a little unbalanced force, so you must have some so precise measuring instruments which can measure so less unbalanced forces, as well as again you will do some corrections, then again you will do retesting, and this process will keep on, this process will keep going on. So we ideally we can achieve completely balanced situation in rotating masses, but for the practical reason, I don't want machinery's cost to be very very high, so we balance it up to whatever possible extent we can have, and then we leave it. That's why you might have seen that even your cooler, which is not so precisely balanced, it has huge vibrations. Washing machines nowadays, latest washing machines, they are quite balanced, up to very high level, but still when rotor rotates, you can feel that, sir, there is some unbalanced forces are there. Even in your computers, on the top of the CPU, we have mounted a fan. This device is ultra precisely balanced, but still you can feel when your laptop or computer's fan switch on, and that fan runs, you still can feel some amount of vibrations. That vibration is very very less, but still due to rotating masses, you can feel some unbalanced forces. Getting my point? And reciprocating masses, on the other hand, sir, even theoretically I was not able to balance it completely, practically just leave it. Even theoretically ideal condition, maybe I cannot balance it perfectly, so we have balanced it partially, and even after partial balancing, I was having some residual unbalanced forces, line of stroke as well as perpendicular to that also. So ultimately we can conclude till this point that whatever machineries we are having, if we are having some rotating or reciprocating masses, so for system mein there will be some unbalanced force remaining, and that unbalanced force is going to create vibration, and that vibration is a very 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 dangerous phenomena. When we talk about mechanical system, this vibration is very deadly phenomena. And why I am calling this as deadly phenomena? Because whenever any system is subjected to vibration, I'm not saying that immediately it will affect, but over the period of time, if that vibration stays for some longer duration, so over the period of time, that vibration affects running life of the system. Running life reduces internally, slowly, because of the vibrational motion, between the interatomic motions. You are going to develop in that system some defects, and those defects, when they micro cracks, when these micro cracks increase in numbers, they club and they form even bigger cracks, and these bigger cracks at the end, whenever system fails, because of these cracks, whenever system fails, your system will show sudden failure, abrupt failure, brittle nature of the failure. Doesn't matter whether your whatever machine you're talking about, that machine was made up of ductile metal or not, it will show nature of failure, brittle failure, fatigue failure we call it. Machine was running, all of a sudden it failed. So vibration is deadly because it reduces the running life of system. Running life of system reduces, and at the end it will have, system will have fatigue failure, and this fatigue failure is sometimes very dangerous. First thing, I am worried that my machine's running life is getting reduced. I am worried about this also. Why I have purchased some machine and that machine is going to fail. Its life is getting reduced because of the vibration. So I want vibration should be as less as possible. If there is no vibration, I'm extremely happy. But if there are vibrations, so I want that vibrations to be very less, as less as possible, so that running life can be as large as possible. On the other hand, even if its running life is reducing, this fatigue failure, nature of failure is very dangerous. Machine is running, and in that running condition, from the outer side, look wise, that machine may not seem to be worn out, may not seem to be an old machine. That machine is running quite good, and all of a sudden when this machine ke parts were rotating about 2000 3000 rpm, and in this running condition this machine is going to fail. So can you imagine, whatever machineries industry may we have, or even your car, at your home you have the car, imagine kariye, if running condition mein any machine is going to fail, you are moving on your car 60-70 km per hour ki speed se, and internal parts of the engines are rotating at 2200 2500 rpm, and all of a sudden if engine ka any moving parts breaks down, that is a very deadly phenomena. It is not only dangerous for the machine, it is also dangerous for the, if some human is involved near about, so that is dangerous for the life also. So whenever we have these kind of deadly situations, vibrations, this study becomes very very important. And my aim is not just to make safe of my machine, I also have to make sure that machine may, if I am talking about generator, suppose, so generator may we are having some rotating reciprocating masses, because of that, because of those rotating masses, entire generator becomes, entire generator has unbalanced forces, and it shakes, it vibrates. So running life of system is decreasing. So I am worried. I will talk about this generator as a machine. Also I have to take care that this generator's vibration is getting transferred to its surrounding, and surrounding may we have something, any other machine which is not running, but still that machine is feeling vibration of the generator. I am not saying that vibration, if it is coming from inside, then only it will be dangerous. I am saying vibration, if it is there on your machine, doesn't matter if it is from the same machine or if that vibration is coming from any other machine, it is dangerous. So I have to make sure that my machine is safe as well as its surrounding is safe. So for this entire chapter, my aim is to ensure safety, to make sure, to make machine or my system and its surrounding safe from the ill effect of the vibrations. Careful. So I will show you what are the types of vibrations we are going to witness in day-to-day life, practical life. What are the different parameters which define any vibrating system. And then we will see that how vibration affects the life, and then we can talk how we can control this to increase the life. We will talk about each thing in a sequence. First thing everybody must notice, whenever we are talking about any vibrating system, so that vibrating system guaranteed it is going to have these 3 or 4 elements. Any vibrating system, any vibrating system, it must have 3 or 4 element. Without these 3 or 4 elements, system cannot show vibration wala motion. Vibration is what? Vibration is just a type of motion, and a system kind of motion, simple harmonic motion. What elements any system is going to have? If it has to do vibration, the very first thing, system must have mass, or I can say kinetic energy storing element. Kinetic energy storing element. That means system must have some mass. It must have some inertia properties. Then only whenever your system is going to have some motion. So because of the motion, system must possess some property because of which it can store certain energy. So during motion, if system is also having mass, so system can have kinetic energy. So you will never come across a situation where people are saying, where question is saying that a massless system is doing vibration. Massless system can never do vibration. If system is vibrating, it must have certain mass. Mass must be there. Second thing, second property, sir, system must also have some property because of which it can store some potential energy. Potential energy storing element. Potential energy storing element, and this is called as stiffness. System must have stiffness. Some kind of stiffness system must have. What are the kinds of stiffnesses? Sir, any system is having all the varieties of these stiffnesses. It is having longitudinal stiffness, torsional stiffness, bending stiffness. Now you tell me which stiffness you are interested in. Every system has all these possible stiffnesses. Like, if suppose this is the pen, if on this pen, if I hold it like this, one end pe I have fixed it, other end ko I am just pulling, its length increases a little bit. Strength of material mein you might have studied that even though this, sir, I have a metallic rod, I am pulling it, its length is not changing, I can't see any visible change. Any visible change you can't see, but if you have applied any tensile force or compressive force, length is going to vary. That will be within the proportional limit, within the elastic limit. It may be very less, may not be visible from your naked eyes, but if you have applied forces, so real metals, this is not rigid, nothing is absolute rigid. Every material under the application of forces, it shows a certain amount of the deflection. This is the nature of any material. So on this metallic rod, on this pen, if I apply some tensile forces, so it elongates. If I apply compressive force, it compresses, its length changes. And if I have applied some forces, because of those forces, deflection is there. But this material has tendency that it wants to, recover its shape. This material has tendency that it also opposes any change in its length. I will say that property is longitudinal stiffness. If the same material, if I fix at one end, other end, say if I apply some transverse load, it will tend to bend. But this material also have property that it will try to resist this bending. I will say material has bending stiffness. Bending को resist करने की tendency, bending stiffness. Or if I twist this, so it also tries to come back to original position. I will say that it is also having torsional stiffness. So that means system has all sort of stiffnesses. Which stiffness you are interested in, that depends which kind of load you have applied, which kind of motion you are talking about, which kind of vibration you are seeing. That stiffness I will take. So stiffness from the strength of materials subject, I am taking some concept like you might have longitudinal stiffness, or you might have lateral, or also called as bending wala stiffness, or you are also going to have torsional stiffness. Torsional stiffness. These are the stiffnesses which any system is going to have. Which stiffness you are interested in, you can decide. Sir, I am talking about longitudinal vibrations or lateral vibrations or torsional vibrations. So accordingly you will select the stiffness, and stiffness ko symbolically I am going to represent in this chapter by a symbol of spring, है ना, by any this, suppose I am talking about this pen, so if I pull it by some tensile force, so its tendency is to restore its shape, spring action. Even if you bend this, so its tendency is to restore the shape, to oppose the bending. So spring action, है ना. There is, sir, is there any literally spring connected here? No. This tendency is spring action, है ना. In our North India, we have that game of marbles. We call it kanchi, है ना. We have some glass balls and we play with that. So even if you take this finger, put a marble here and stretch your finger back, and the moment you release it, so because of the stiffness, this finger automatically goes back, है ना. Stiffness, everything is having certain type of stiffnesses. So do I have any spring here on this finger? No. But if you are stretching it like this, the moment you release it, it goes ahead. Why? Sir, because of the spring action. That tendency of resisting any, force, resisting any deformation here because of some external force, that tendency is similar to spring behavior. So that's why symbol I am using as a spring symbol. So material ka stiffness ko I can represent with this spring symbol. This is symbol, है ना, and its stiffness in this chapter I am going to show with S stiffness. Books में you might find people will also write this as K, है ना. You can write this S or K. On the other hand, any system which is doing vibrational motion, so when system vibrates, it is doing some motion, and whenever I talk about motion, we are actually talking about relative motion. Any system is moving with respect to surrounding, and with respect to surrounding, if my system is moving, so obviously बात है relative motion की वजह से we are going to have certain friction. So there must be some friction. Obviously बात है, some friction must be there. Friction means energy losses. System is moving with respect to surrounding, so because of the friction, its energy is getting lost. Slowly its energy will also get lost. Obviously बात है. And again, as a symbol, just to show the relative motion, I am showing this damper as a symbol. What we have, this is a piston inside. I have a cylinder inside that I have shown a piston. So this thing is a symbol, damper, and this is, let me write, this is damper, and this is my spring. Symbolic. These are symbols. Friction is there, and whatever friction is coming around, that friction ko symbolically I am representing with damper. Damper is just showing that in cylinder ke andar, inside the cylinder we are having some piston. It is moving, showing the relative motion. With respect to cylinder, this piston is moving. It is showing that relative motion is happening, so friction is there. These three things definitely are going to be there. Any system which is going to have vibration, mass must be there, stiffness must be there, and there will be some friction. Friction ko you can never make it zero. You can reduce the friction, you can make surfaces ultra smooth, you can use very beautiful lubricant, but you can never guarantee that I have make friction zero. Friction is never zero. You can reduce it extremely, you can reduce it, but zero, it's impossible. And the fourth thing might be your system is also having its own continuous unbalanced forces. So system can have some unbalanced forces also. Any vibrating system is going to have these four things, or at least these three things. If we are having system which is having these three things, system is having mass, some stiffness wala property, and some frictional energy losses. So here, if system is having some vibration, I will say that this is your damped vibration. It is called as damped vibration. Acha, if system is only having these three things, so to initiate any kind of motion, you must initially provide some disturbances. System is on its mean position, system is quietly sitting. you have to provide a little disturbances, disturb the system, release it, and then it will show some kind of motion. That motion is vibration or not, I will check, but then only you can start some motion. You can imagine, suppose this ceiling fan you have, है ना, ceiling fan का blade, or at your home you might have a scale. Take that scale which is used to draw that line, take that scale, hold it at one end, other end ko just release it only. It will be at its mean position, sitting quietly. What is this system is having? This system is having mass, some stiffness. If you bend this, it tries to go back. Stiffness, bending stiffness. And surrounding me we have air. So air is, if this system moves, so air's drag will apply some friction. So friction is also there. There is no unbalanced force. Here in this setup, there is no unbalanced force. So you must provide some initial disturbances to initiate any kind of motion. What you are doing? You have taken this, disturbed this. Disturb ka matlab hai from the mean position, take it downward or take it upward. From the mean, like this or this. You have from the mean, you have taken here. Like this is the blade. From the mean position, you have taken it here. I'm not saying that bend it. I'm not talking about permanent deformation. I'm saying just slight disturbances. And once you release it, this goes, because of the stiffness, it goes back to the mean. But if friction is not sufficient enough, so this starts doing this kind of motion. This motion I'm calling as vibration. So can you see? If we are talking about only mass, stiffness and friction my system is having, so I must provide some initial disturbances. Then only system can have some motion. And why I'm creating this suspense? Sir, why are you not saying that if these three are there, damned vibration will be there? There are so many situations where friction is very, very high. And if you disturb the system from the mean position and release it, it moves, it will show some motion, but that motion is not vibration. That system moves slowly and gently goes to the mean and stops. Friction was so high that when systems, first of all, system is not moving very fast, system is very, very slow, and because of the friction, whatever disturbances you have provided, disturbance ka matlab hota hai you have given some energy, so you have taken system here and now release this system. So this has moved to the mean, and only till this motion, entire energy is lost in the form of heat. Why? Friction is so high. So if friction is low or friction is high, depending on that, we will decide whether vibration will happen or not. If vibration happens, it will be called as damped vibration. Damped vibration ka matlab hai ki you have disturbed the system, release it, even if it vibrates. So because of the friction, slowly this energy dissipates, and after some time this vibration is going to vanish. Obvious si baat hai. And sometimes we might have its own unbalanced force. System might have unbalanced force also, mass, stiffness, friction, as well as unbalanced force. So in this situation, I don't need to provide any kind of initial disturbances. Like your bike. And a bike mein, sir, bike is my system. My house, in my house I have a cooler. Cooler is my system. So when I'm talking bike as my system, bike may, to initiate any kind of vibration, I don't need to disturb the bike. Sir, bike was standing and bike pe I have slapped it. I have not disturbed this. No. Bike may just switch on the bike, start the bike, and inside the bike we have engine. Engine may we are having some piston and rotating reciprocating parts. These parts start motion. These parts are not perfectly balanced. In the last chapter there was balancing, but we couldn't perform complete balancing. And because unbalanced force is there in the system, so because of that moving piston, unbalanced forces are there. Those forces gets transferred to the engine. From the piston, it gets transferred to the cylinder block. Cylinder is mounted on the chassis of the bike, and that entire bike rotates. That entire chassis vibrates. So what you have done here, you just have started your bike. Any rotating reciprocating part, if it is there, if it is not perfectly balanced, it will have its own unbalanced force, and because of that, you just start the machine. कूलर में, घर में, सर आई हैव द कूलर, कूलर, जस्ट स्विच ऑन द कूलर, exhaust moves, and once exhaust has started motion, it is not perfectly balanced. Because of this, entire cooler ka body shakes, vibrates, है ना? And this kind of vibration is called as forced vibration. Forced vibration. Acha, everybody can understand this. I haven't yet started my chapter, but I hope everybody can feel this, that sir, vibration, if it stays too long in your system, it is dangerous. So sir, even if your system is having damped vibration, I don't think it is going to stay too long. Why? Arey bhaiya, friction is there. Same, take the fan blade, bend this a little, release it. Even if it is vibrating, so because of the air friction, after some time, after 30 seconds, 50 seconds, 1 minute, 2 minutes, it will stop. So I don't think that this kind of vibration is staying too long in your system, so that it can hamper the running life of your system. It is not dangerous at all. What is dangerous? Long time tak if I am having vibration, post vibration, sir, my bike, my car, my cooler, my household mixie, washing machine, my AC, everything, my computers, computer mein CPU ke upar we have some fan, everything which is having some rotating reciprocating parts which is subjected to forced vibration, this forced vibration is dangerous. Wherever we are having machineries with parts are moving now. So whenever we are having this, till the time machine is running, unbalanced forces will be there. These forced vibration will remain in your system. And if system mein we are having vibration for longer duration, it affects the running life. So I hope you have understood that we are going to study vibration. We are going to have only two varieties of the vibration in your life. First, we can see damped vibration. We can also see forced vibration. This forced vibration is dangerous. Ultimately, we have to discuss what is the forced vibration. Ultimately, we will come to this forced vibration. But studying forced vibration is not a easy task. Why? Sir, forced, any system which is having forced vibration, it is having mass, stiffness, friction, unbalanced force. These four parameters. Even understanding damped vibration is not that easy because it is having three parameters. So nowadays it is easy because we have developed so beautiful mathematical tools. Earlier days when Mr. Galilei was experimenting, he was doing a study of this vibrational motion. At that time, even mathematics was not so developed. So he made some assumptions. What assumptions? To make things simple, to make calculation easy, he made assumptions. What assumptions? First assumption he made, I will not study machineries. I will study only those situations where unbalanced force is zero. So first assumption, unbalanced force ko I am taking as zero. Okay, I can understand that you are not talking about your bike, you are not talking about your car. Then what you are talking about? You are talking about any system which is not having any unbalanced force. Non-machineries part we are talking about. Like at your home, you are having door. So door is non-machinery part. But can it vibrate? Yes. Door, if you just go and slap it, you have disturbed this. At mean position, it was simply sitting quiet. If you just take the door, slap it, it shakes for some time. Even that fan blade ka example, bend this a little bit, release it, it vibrates for some time. So everything which is non-machinery will fall under this category that, sir, theek hai, unbalanced forces are zero. So that means you are talking about few things which are non-machineries. Sir, my house structure, this is having column beams, this is non-machinery part. If even here, if vibration comes, so it will fall under this category where unbalanced forces are zero. ठीक है. Second thing, this is quite clear that Mr. Galileo is not talking about machineries. Second assumption which Mr. Galileo has taken, it was that friction is also zero. Friction is zero. Friction का मतलब है energy loss is zero. Energy losses are zero. Sir, this assumption is non-practical. Why? You are not talking about machineries, I'm okay with this. But if you are saying that friction is zero, that is very, very difficult, non-practical situation. Even, sir, this fan ka blade, which I'm talking about, just hold it at one end. Other end ko, if you have disturbed this a little bit, released it, it shakes, it vibrates. And when it is going to have this vibrational motion, from where friction is coming? From the surrounding. Surrounding mein we are having air. So air surrounding, and surrounding ke respect mein this blade is moving. So some drag, some friction is there. Sir, what if from the room I, take out this entire air? Can you guarantee you have made perfect vacuum? No guarantee. So first of all, sucking entire air is not possible. Even if you say, sir, then sir, I have made, entire air, I have taken out from the room, perfect vacuum is there, then I will say ki air is not applying the friction when your body moves. So this particles of this body, interatomic forces, these four particles which are moving, these friction, interatomic friction, I will consider that. Alright, sir, that is very, very less. That's very less. But you cannot say that it is zero. Friction ko you cannot say zero. I ultimately want to say this. है ना? You can never say that friction ko I have made it zero. Friction can be less. It can be very, very less. But zero, that's impossible. है ना? And this thing, friction ka zero, this assumption makes whatever study Mr. Galileo Galilei has done as pure mathematical phenomena, hypothetical situation. And based on these two assumptions, whatever study we have done, that is called as natural vibration, or more clearly, it must be called as undamped natural vibration. I hope this is clear to everyone. So natural vibration mein what we are going to have an example. Whatever now I am studying, it is not practically possible, not at all. Whatever we are studying, it is not practically possible, but this examination mein, it is very, very important. Examination mein so many varieties of the questions are framed here. Natural vibration. So what we are having when we are talking about natural vibration, we are having system is having mass, system is having some stiffness, mass as well as system is having mass and stiffness. How do I show this? I have shown my system as the same system. Sir, you are talking about fan blade, I am talking about this fan blade only. So whatever its mass, I will show that mass as a concentrated block. Mathematical representation, I am telling you. I have some real system whose mass is something, so that mass I have represented as block, concentrated block. And it's whatever stiffness, sir. In that fan blade wala case, I am talking about bending stiffness. So bending stiffness ko spring property se I have shown ki one end pe you have fixed, and whatever is the bending stiffness, that stiffness is represented by this spring, and we are having this mass. Very, very careful. This is the mass. Stiffness of the system is S, Newton per meter, and mass is given as m kg. Imagine kariye that this spring is in its unstressed form. You have connected this mass here. Still, you have holded it. You have not released it. So this is called as your initial position. This is called as your system ka initial position. Initial position. But the moment you release this system, release this mass, slowly, weight is acting downward direction में, so because of the weight this mass comes here, weight is acting in downward direction, because of this mass goes down, a spring stretches, and once this spring gets elongated, spring is applying some force in upward direction, still weight is more, so it goes down, spring further more deflects, it is applying even more force. There will be some situation where spring has elongated sufficiently, and now weight whatever is acting downward direction mein, weight is balanced by spring forces, further it is not going anywhere. So this position I am calling it as mean position of the system. This is the mean position of the system. We also call it as zero position of the system. And if you will not disturb this setup, this spring mass setup, if you will not disturb this setup, this will remain at this position only for lifetime. It will remain here only. Why? Why? There is no unbalanced force here. If you have to see any kind of motion, you must disturb this system. Then only it will show some kind of motion. Clear hai baat? Friction I have assumed it to be zero. Energy losses wala friction. Energy loss ke liye, for the energy losses, responsible friction is kinetic friction. So that kinetic friction is zero. Let me write it somewhere. Friction is zero, energy loss wala friction. That means kinetic friction. I am saying it zero. Kinetic friction is zero. And this distance from the initial to the mean position is called as static deflection delta. This is static deflection delta. How much will be this delta? You can simply say, okay, sir, at this mean position downward direction we are having mg. Can I say this? At this mean position we are having downward direction mein mg force, and spring has elongated by some delta amount, so it will be applying opposite direction mein some force. Spring ka force will be s delta, and these forces have balanced each other. So s delta, which is upward direction mein, mg which is in downward direction, they have balanced each other. How much is the delta? Sir, mg divided by s. This is called as static deflection. Static deflection. I hope this is clear to everyone. Now this setup is resting here. It is chilling out here. Now if you have disturbed this system, what is the meaning of disturbing the system? You have taken the system from here somewhere till this point and released this. It will have some motion. One way of disturbing is this. Okay, sir, you have taken it here and at this position you have taken it at some x distance and you have released it. The moment you release it, now this system is doing some motion on its own. On its own, it is doing whatever it wants to do. It is doing on its own. That's why I am calling it as natural vibration. It is natural motion of the system. I just have provided the disturbances. What this system has to do, system will decide. I'm nowhere. I just provided the initial disturbances. So you can provide disturbance like take it here, release it. So I will count my time t equal to 0 from here. Okay, at time t is equal to 0, what my system was doing? My system was from the mean position, it was at x distance, and at the time of releasing, its velocity was 0. Its velocity was 0. One way of disturbing. Another way of disturbing is you can also disturb it. That system is chilling out at this mean position. You just hit this system and it will start doing some motion. Time t is equal to 0. I will start counting from there. That time t is equal to 0 per, I haven't provided any deflection, but I have provided some velocity. Or you can also go some extreme. Okay, sir, time t is equal to 0 per, what I have done, I have pulled it till this point, and before releasing I also have given it some velocity also in the downward direction or upward direction. You can anyhow disturb these three methods of disturbance I have shown. You can disturb in any of these three methods. And once system is out of your hand, now what the system is doing, I don't know. System is doing some motion, so I want to know what that motion looks like. Somehow, if anyone can tell me that at any time, once system is doing motion, so it is doing certain type of motion. When I saw at some general time t, I found that my system, from its mean, it is at some x distance, and it was at this position, it was further going down with some v velocity, a acceleration. How do we solve this situation, sir? X as a function of time t, if you can find out this, then velocity, acceleration very easily we can find. कैसे निकालेंगे भाई? X as a function of time t, if you know, so velocity क्या हो जाएगा? Velocity is dx by dt. Acceleration क्या हो जाएगा? Another time just differentiate this, d2x by dt square. Velocity को I am writing as dx by dt. अच्छा, dx by dt को in this chapter we can write as x dot. X dot is representing x को you have differentiated one times. d2x by dt square, it means x double dot. यानी कि x को we have differentiated two times. Is this clear or not? What is the meaning of x dot, x double dot? X dot is showing velocity, x double dot is representing the acceleration. So my aim is, somehow you can tell me, if you can tell me what is the value of x dot, x velocity, acceleration, I can found. And whenever any system is doing vibration, so what special thing you will feel, that its x, whenever we are having vibration, so its x is going to be a function of time t. How? Sinusoidal function of time t. X will be changing as something 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 sin t. This kind of feature I am going to have. ठीक है? X के साथ this x is equal to sin t something. Whatever we are having here, that is something which is called as amplitude. This is called as amplitude, and whatever is here in multiplication with time t, this is called as frequency of the vibration. So I will somehow write x as a function of time t. If that x looks like this, x is something sin something t, I will say that my system is doing motion. That motion is vibration. Vibration of what amplitude? Sir, this amplitude. Vibration of what frequency? This frequency. Clear hai baat? Acha. How do we solve this? Careful. We have to talk about this situation, and at this mean position, already my weight which is acting on the system was balanced by initial springs के deflection. Spring का S delta and mg, they have already cancelled each other. So from the mean, here total force is 0. System is in equilibrium. Further motion कर रहे हैं, we are doing some motion. Further we have traveled this distance x, v velocity, we are moving. Additional forces, how much have been generated? I will write that. कैसे बात करेंगे? To analyze motion, what approaches we can have? Let me show you that. Sir, one thing you can have is, sir, this is the initial position, this is my initial position, and system was here. Initially system was here. It has come down till this mean position, and till this mean position, can I say simply, here already mg has been balanced by S delta, initial deflection of the spring, and mg have been balanced. Now further from here, how much this system has come? System is here. From the mean position, this is your mean or equilibrium position. So x I am considering from here. You are at x distance, and further you are going, system is going with, it is moving with some v velocity, a acceleration, like this. I want to solve this. Now to solve this situation, we are having basically three methods, three very very important methods. What are these three methods? Every method is very important. First method, we call it as FBD method, free body diagram method. Another method we call it as Rayleigh method. Another method we call it as energy method. Energy method. Using any these three methods, you can solve this question. First of all, let's talk about free body diagram method, FBD method. FBD method. What is this FBD method? FBD method, as name suggests, that we are going to draw free body diagram. And free body diagram, how I am making? So that here at initial position, you are just holding this mass. Really, you have released it. So because of the weight, system is coming here. Here, system has got equilibrium position. S delta and mg are balanced. Now further, because of the disturbance, system was moving. So from the mean, you have traveled some distance. You are moving with some v velocity, a acceleration. Now tell me what additional forces are coming. You can either apply Newton's second law. What this Newton's second law says? What this Newton's second law says? It says that on any body, if it is moving with some acceleration, so this body ke liye I can write net external forces acting on this body are equal to mass into acceleration. We can write it like this. Net external forces acting on this body is equal to mass into acceleration. We can write it like this. This is Newton's second law. So on the line of motion kya hai? Sir, this is moving in vertical direction. So line of motion mein what are the forces? What forces you can see? Sir, one force I can see. From here, you have further moved down. So additional spring ka force will be Sx. By this mass is connected to spring, so spring has applied some force S into X. Any other force? Sir, I can't see any other force. So how can you write this? You will write this as, sir, body is moving further downward direction with some acceleration. This is my assumption that it was from the mean, it was at x distance, further v velocity, a acceleration se it was moving. So downward direction mein a acceleration se why it is moving? Because there must be some external force in downward direction. Downward direction mein, sir, how much resultant force? Sir, downward direction there is force 0. Upward direction mein force is Sx. So 0 minus Sx. By downward mein, how much resultant force is there in the downward direction? 0 minus Sx. Sx is upward direction mein. So this is downward direction wala force will be equal to mass into acceleration. We can write it like this. So take Sx that side. I'll be having mx double dot plus Sx is equal to 0. That becomes your equation of motion. Whatever this mass is doing motion, equation of motion is this. That motion is represented by this equation. Or we can also use D'Alembert principle. क्या कर रहे हैं? What is the meaning of D'Alembert principle? D'Alembert principle, what does it says? It says that whenever we are having any accelerating body, so by sitting on this body, on this accelerating body you are sitting, accelerating frame of reference where you are sitting, and now you are seeing the motion. So this guy can write whatever forces in this direction of motion we are having, write all these forces. What are the forces? Sir, I am having a spring ka force Sx. Any other force? Sir, mg is also acting. Arre bhaiya, mg, if you will write mg, I will write these S delta forces also, they will anyway get cancelled. So not, please don't talk about mg and S delta. They have already got cancelled at the equilibrium position. So additional force from the mean, when you are here, additional forces are what? Sir, Sx. Any other force? Sir, no other force. So acceleration ke opposite direction mein just apply inertia force, and summation will become 0, summation of forces will become 0. So spring force you are having, acceleration is in downward direction, so just apply mx double dot inertia force. This is your inertia force, just apply inertia force, and all these forces का summation becomes 0. क्या हो जाएगा? mx double dot plus sx is equal to 0. That's it. What this D'Alembert principle says? D'Alembert principle says net external force plus inertia force, this summation is 0. This is what I have written. So all other forces plus inertia force. Inertia force is always opposite to acceleration. Okay, acceleration is in downward direction, so this force, inertia force, will be upward direction में. If the body का acceleration is in upward direction, so inertia force will be acting in downward direction. Inertia force के बारे में in the last few classes I have done discussion. I don't think that anyone is having any problem here. Till this point, tell me if you are having any problem or not. बताइए. Next, this is the equation of motion. Its solution is going to decide whether we are going to have vibration or not. Careful, careful, careful. We are having equation of motion as mx double dot plus sx is equal to 0. This is equation of motion of what? Of natural vibration. Any system which is doing natural vibration, its equation of motion is given by this, and its solution by doing some mathematical circus, second order का differential equation we are having, x double dot x we are having here, second order का differential equation it is. So once you do solution of this, its solution comes out to be x is equal to r sin omega nt plus phi, something like this. Solution looks like this, and in this solution, this r and this phi is constant. This r and phi, they are constant. They are constant. Acha, once you have solution with you, can you see x is sin t kind of something. Presence of sin is telling you that this motion is vibration. Of what amplitude? Sir, this r represents the amplitude of vibration. Amplitude of vibration. And what frequency? Sir, this omega n is the frequency of the vibration. This is frequency of vibration. And this omega n is equal to what? Omega n is equal to under root s by m. Something like this we are going to have, under root s by m. Yes, but I am taking it from the very basics, है ना? So, and I'm not talking about any difficult concept, any difficult questions here. I'm just giving you an idea of the chapter, what this chapter is going to contain, है ना? So, after watching this entire series, you will be having a clear, good idea that what theory of machine is, what each chapter is all about, है ना? What is the level of gate, how questions are framed, from which topics questions are generally framed, every idea you will get. Clear hai baat? Acha. Sir, these are the constants. How can I find these constants? Can you tell me something about this? These constants we can find with the help of initial conditions. Find from initial condition. क्या मतलब है? अरे भाई, we have some initial disturbance condition ना. At time t is equal to 0 पर what was my x, what was my velocity, you know about this. Time t is equal to 0 पर x is something, velocity is something. You have you have provided the disturbances, so you know that time t is equal to 0 per, while releasing the system, what was my x, what was my velocity, you know this. So from those two equations, x and velocity, you know, so you can find out these two unknown constants. These two unknowns you can find out with the help of initial conditions. And once you have calculated what is the value of r, what is the value of phi phase angle, put these values here, you have now perfect solution for your system's motion. And when I'm saying that this r is constant, what does it mean? This means that during motion this r don't change. How does it look? Sir, we are having a setup like this. We are having this spring. This is the mass. Spring का stiffness is S. Mass is given as M. And suppose I have taken this system from here till this point. I have provided this much disturbance, and from here I am releasing it. So the moment you release this system, how does it move? If I'll show its motion, कैसा दिखाई पड़ेगा? Sir, you have released this system from here. It starts moving like this. It goes, it comes down, it goes up, it comes down, it goes, it comes down, and it will keep on doing this vibration. It will keep on doing this vibration. This is simple harmonic motion I am talking about. And this simple harmonic motion mein, what is R amplitude? Sir, this value is R. R amplitude. Whatever is the amplitude from the mean position, extreme, how much distance it is, this R remains constant throughout the motion. And this motion will keep on going till infinite time. Why? Sir, friction is not there. Friction could have reduced this, amplitude because of energy dissipation, but there is not friction. There is no friction. So this vibration will keep on going lifetime. Lifetime. Clear hai baat? So exam mein they can ask question, what is the amplitude? Sir, R. We can calculate from the initial condition. Sir, what is the frequency? Exam mein most of the time they will be asking, tell me what is the frequency? Frequency is omega n under root s by m. And this under root s by m is omega n is under root s by m. Stiffness ko if you have put in Newton per meter, mass ko if you have put in kg, all mks, so omega n comes out to be in radian per second. This is called as circular frequency of the system. Circular frequency. Unit is radian per second. And omega n, we can also write this as 2 pi by time period. Natural vibration की बातें हो रही हैं, so we can write this as 2 pi by t, n, suffix में n. Why? Because we are talking about natural vibration. If we are talking about damped vibration, I will write t suffix में d. Omega d, td, like this. So omega n can be written as 2 pi by t or 2 pi f n, like this. What is this f? F can be written as 1 upon 2 pi times omega n, or if we'll put the omega n ka value, so it can be written as 1 upon 2 pi under root s by m. What is this f? This f is called as linear frequency. This is the linear frequency. Hertz is the unit. Linear frequency. Hertz, or number of cycles per second. Cycles per second. This is the unit of this. What is it? T? T is the time period. T is 2 pi by omega n. Like this we can write. Or put the value of omega n, so you can write it as 2 pi under root m by s we will be having here. Put all these values in mks, so this is time period. Its unit is second. Tell me in the chats if you are comfortable or not. Examination mein they will be giving spring mass system, or any system whose stiffness is represented as spring and mass, है ना, stiffness is represented as spring and mass को concentrated blocks से they have represented. So this spring mass system they will be giving, and they are going to ask, tell me what is the frequency under root S by m. That's it. That's it. This kind of questions examination में they are going to ask. अच्छा, natural frequency only it is depending on what is the system का stiffness, what is the system का mass, and system की stiffness, system का mass is property of the system. So omega n is the property of system. Omega n, which is under root S by m, is property of the system. This is property of system. So doesn't matter whether you have put your system like this, I don't care whether you have kept your system like this, where this is your mean position, this is your mean position. If you will disturb the system, it will do vibration, and that vibration will be like this. What is the frequency, what is the time period, what is the omega n, that is fixed. System का property है भाई. Or if you are going to put this system like this, horizontal, if you have put this system, sir, on a plane surface I have kept this mass, frictionless surface we have, this is a smooth surface, there is no friction, perfectly smooth. Take this mass, pull it, spring elongates, release it, it goes, you know, to and fro about this mean position. System will have some vibration. So this kind of vibration we are going to have. You keep system like this, or you keep system like this, or even if in some wedge shape, inclined plane, if you have kept your system, even here also everything remains same. How this system is going to behave, that doesn't depend how you have kept your system. Tell me in the chat box. Till the time stiffness and mass are same, S and M is same, my omega n for all these three systems is under root S by m. That's it. That's it. Tell me in the chats if you can understand this beautiful concept or not. System का property है spring mass system, whether you keep it like this or keep it like this or you keep it like this, natural frequency is not going to change. Under root S by m means under root S by m. An exam may they have asked questions, you know, based on these simple concepts. Sometimes they will give in the examination, sometimes they will directly give equation of motion like this. Bhaiya, any for a system, for a spring mass system, equation of motion is given as something 5x double dot plus 7x is equal to 0, something like this. This is the equation of motion, and they will simply ask, tell me, find what is the omega n. Natural frequency is how much? This easy questions even gate mein they have asked. How can I write? Arey sir, just compare it with mx double dot plus sx is equal to 0. So what is mass m? This is 5, s 7. So can I write omega n is how much? Under root s by m, 7 by 5 radian per second. That's it. बताइए बेटा. First variety of the question they can ask this, है ना. Second thing, sometimes they say that springs are in series, parallel, multiple springs they can give. What does it mean? Let me talk about combination of spring. Combination of spring. We are having first case, if springs are in series. Springs in series combination. How does it look? Sir, it looks like this. We are having one spring, another spring, S1 stiffness ka spring, S2 stiffness ka spring, and we are having this is the mass. So if you just tell me one spring mass system, under root S by M is the answer. But you have given me some multiple springs. How do I know? Somehow, if you can just tell me that all these springs collective, what is their effect, and just represent this combination using a single spring, equivalent spring, and this is the mass, same mass M. Just tell me these springs in series combination, how much is the equivalent stiffness property here? Just tell me that. If you can tell me what is the equivalent stiffness, so I can write omega n is equal to under root S equivalent divided by mass M, and equivalent stiffness for the series combination, it is 1 upon S equivalent is equal to 1 upon S1 plus 1 upon S2. That's it. Harmonic mean. Just put the value of S1, S2 here, take harmonic mean, equivalent stiffness you will get, and you can write omega n as under root S by M. It is that easy. Sometimes springs are in parallel. How does it look? Second situation. Springs in parallel combination. What is the meaning of parallel combination? Acha, parallel combination doesn't mean springs are looking parallel. No. I'm not saying that they looks parallel. No. Parallel combination means something. What does it mean? If I'm having one spring here and another spring here, this is my S1, S2 stiffness wala spring. I have, this is mass M. These two springs are in parallel. When I say springs are in parallel, that means that if I apply some force here, so suppose I have applied 10 Newton ka force, so that 10 Newton ka force will get distributed in these two springs. If this spring is having 6 Newton, so other spring is going to have 4 Newton. This force will get distributed among these springs in such a way that both these springs will show same deflection, exactly same deflection. Parallel combination, what is the its key property? Springs, let me write, springs must have same deflection. If this is the case, then only you can say that these springs are in parallel. Sir, in this case, if you pull this mass, so by whatever amount mass comes, it is a concentrated block. So whatever amount of mass is coming down or going up, both these springs are showing exactly same amount of deflection. Then I am saying that these two springs are in parallel, and if these springs are in parallel, so equivalent stiffness S equivalent can be written as S equivalent is S1 plus S2. I'm just avoiding the derivational part, that sir how this formula you can write here. There is some logic behind it, there is some derivation behind this. I'm just skipping that part. You must remember these results, that equivalent stiffness is S1 plus S2. And once you have equivalent stiffness, omega n is equal to under root S equivalent divided by mass M. This is how you can write it. I hope this is clear to everyone. Clear? Is this clear to everyone? Acha. Sometimes they can have a situation like this also. Sir, what do you think about this? S1 stiffness, S2 stiffness. What do you think about these springs? Which kind of combination it is? Is it series combination or is it parallel wala combination? क्या लगता है? Tell me in the chats. What do you think, beta? Can anyone answer? What kind of connection it is? देखो, I already have said that parallel connection doesn't mean that springs are looking parallel. नहीं, parallel का there is some logic that whatever force you are applying, that force is getting distributed, and deflections of springs is exactly same. So even in this case, if you disturb this mass, if you take this mass by some amount down, this spring and this spring, both springs are showing deflection of the same amount. Deflection same hai. One spring may show elongation. This spring elongates. This spring gets compressed by same amount. Deflection is same. I'm not saying both springs must elongate by same amount. Deflection is same, and force is getting obviously getting distributed in these two springs. So even this case is parallel wala combination, and if it is parallel wala combination, so whether you show it like this or you can also show it like S1 stiffness, S2 stiffness, you can show it like this also. This is mass M. Tell me in the chats. Same है ना? Examination में गेट में 2014 में for 2 marks they have asked this question. क्या कह रहे हैं क्वेश्चन में? क्वेश्चन में they are saying that we are having a mass on this inclined surface. It is kept S1 and S2. These are the two springs which are connected here. Tell me what is the natural frequency of this system. How many of you can feel that sir, as K1 K2, these two springs parallel wala situation hai. This side it is fixed, this side it is fixed. Spring in between we are having some mass. So springs are in parallel. Can I write S equivalent is going to be how much? S equivalent is S1 plus S2. So omega n will be how much? Under root S1 plus S2 divided by mass is M. That's it. This question for 2 marks. Can you imagine this? Which option is correct? I think option D, Delhi, is correct here. Arey Bhanu, beta, how your question is relevant in this situation? Theory of machine and vibration mein, how this question is relevant? You are asking anything. ठीक है? I am having no idea about this, that batch D has been removed. I will just check and I will get it confirmed, है ना? I will answer your question in my Telegram. If you can ask me in the same question, just write in my Telegram group, or tomorrow session mein when I'll meet, I will discuss this. Ki what happened with the batch D. if anyone from the tech team is monitoring the chats, students are asking for the batch D. Please give them some clarity. Okay, I have no idea about this. Let me get in touch with my team and I will confirm whatever is the answer. I will confirm tomorrow. चलो, ये बात समझ में आ गई. Everyone is comfortable till this point. Very easy, very easy. Then another method is there. Pre-body diagram method we have just seen. Sometimes here we have talked about that we are having a spring, we are having mass is going up down, linear motion it is doing. So we have talked pre-body diagram in terms of forces. Sometimes pre-body diagram, but if our system is having rotational motion, so instead of talking in terms of forces, it is easier for us to talk in terms of torque. How that situation looks? Suppose if I'm talking about my pendulum. Careful, I'm doing nothing new. I'm having a pendulum. How does it look? Sir, I'm having this thread. It is not a spring, it is a string or thread whose length is given as L, and at the end I have a point mass. Suppose this is point mass M, a small point mass M. One end pe I have, fixed this thread. What kind of vibration we are talking about? Sir, if you are not disturbing this system, it stays at this position, it remains at this position. How you are disturbing this? Now I am taking this mass from here till this point and then releasing it. So it comes back to the mean, but it doesn't stop. It also goes this side, and now it will continuously doing this kind of motion. I am talking about this kind of oscillation. And can you feel, sir, this mass, whatever motion it is having, it is easier for me to talk about its rotation. Its rotation from where? From that position from where I can see its pure rotation, I center se. So there is method which is called as torque method. Nothing new. We are talking about torque method, and torque method is applied from where? From where you can see the pure rotation. Pure rotation can be seen from the eye center. So I am directly adding applied from eye center. Where is the eye center? So from this location. If you are sitting at this location, now this body ka motion, there are two ways to talk. One person can say, okay, sir, when I saw this mass was moving in this circular arc wala part, this arc mein it was moving. So one person can say, if you are seeing the linear motion, you can say it like this, कि sir, this mass was here, it has traveled here. You can say motion parameters as that it is at some x distance. When I saw, it was at some x distance. Further, it is moving with some v velocity, a acceleration. When I saw this. Now, what forces are acting? You can analyze the forces. In the direction of motion, what are the forces? Sir, forces kya honge bhai? Forces ke naam, on the name of forces, I am having only this weight. And this is the thread. Thread is here. So some tension T also. But sir, I am not interested in this mg and tension T. I am interested in only in forces which are acting in the direction of motion. Tell me forces which are acting here. So I will take some components. So this mg ka, I will take one component here, one component here. So I will take some components, and then all forces plus inertia force summation is 0. You can write it like this. One way is this. Let's try solving by this method also. How you can write forces ka summation is as 0? Sir, if your this thread has traveled some theta angle. You have moved by x amount. Further, x dot velocity, x double dot acceleration. So you are moving. So what are the components of this mg I can take? Mg ka one component will be here, and one component will be in this direction. Let me zoom this a little bit. How many of you can feel if this angle is theta? So this angle also it is going to be theta beta. This will also be theta. If this is theta, so this is your mg. Mg ka this one component will be mg cos theta, and this component will be mg sin theta. Very, very careful. And how do we talk? We talk like this, that in the direction of motion, whatever forces are acting, just write all those forces. Sir, tension T and mg cos theta, they are perpendicular direction. They are not of our use. I'm just talking about forces which are in perpendicular in the direction of motion. So in the direction of motion, I am only having mg sin theta in this direction. So what forces we are having? Sir, we are moving in this direction with at x distance with x dot velocity, x double dot acceleration. Force, here we are having how much? Mg sin theta. Any other force, sir? No other force. Ask D. Lambert bhai. He will come with his inertia force. Inertia force, wherever you are moving with acceleration, opposite direction mein inertia force, mx double dot I will apply, and summation of force will become 0. One thing is this. One way of writing is this. So all the forces mx double dot plus mg sin theta is equal to 0. Equation has been written. You can just simplify this by ultimately I want equation in terms of x. So x double dot x I must have. If you are having sin theta, so can I write, sir, for small theta, sin theta ka value is almost theta. So you can write this as mx double dot plus mg theta is equal to 0. And even this theta you can write something. Can I write this? If very small thetas ke bare mein if I am talking about, so this theta angle is radius and this arc. Actually arc is something different, but if this arc is very, very small, so this linear distance x and arc are almost same. So can I write L theta is arc x? लिख सकते हैं क्या? Sir, can I write L theta is x? So theta can be written as x by L. Wherever we are having theta, put this value. What you will be having? This mx double dot plus mg x by L is equal to 0. I think few mass is getting cancelled. Ultimately, I am having x double dot plus g by L, x is equal to 0. This is how you can write your equation. That's how you can write your equation. And if you can compare this, mx double dot plus sx is equal to 0. If you will just compare it by that equation, so you will see that this thing divided by this thing is 1. So only this thing is becomes your, this is going to be your omega n under root g by L. Simple si baat. You can write it like this. Bhai, ultimately, what earlier I was doing, I was just having, where is the equation, sir? I was just having, whenever I get mx double dot plus sx is equal to 0, I can write this, rewrite this as x double dot plus s by m x is equal to 0. And whatever is written here, this one, this is omega n square. That's why I have written omega n as under root s by m. So what I have done in this situation, sir, what you have done here, x double dot plus something x is equal to 0. So this under root g by L is representing, this is representing your omega n square. Tell me in the chats if you are comfortable here. ठीक है. Now another example for the torque method. Acha, this question I have solved by taking motion parameters as x dot, x double dot. Careful. When you are talking about linear motion, so I'm saying x dot, x double dot, these are my motion parameters. My mass was at x distance, moving with v velocity, a acceleration. But if we are talking about torque method, rotations we are seeing, so I will rather easily talk about theta. My system is at theta position, and theta dot velocity, theta double dot acceleration, say it is moving. Theta dot is nothing but omega velocity or alpha acceleration. What is this? X dot v velocity, a acceleration. So let's talk same question, sir. Equation I have made, but theta was coming into picture. Now converting this theta into x, it took some time. What if I directly write this solution equation of motion in terms of torque only? How does it look? Same question. Now let's try solving this by torque method. Same question. Answer will be exactly same, and it will be a little easier, less time consuming. So torque method के लिए क्या बात करेंगे sir? Forget about this x. Forget about all these things. I'll be applying torque method by sitting at this location. This is the eye center. From here I can see the pure rotation. What? Sir, from this eye center, when I saw system was at the mean, and it, upon disturbing, it was doing some motion. When I saw at any general time t, my system was moving like this. When I saw from the mean, it was at theta angle, and further it was going with some omega velocity, alpha acceleration. So it has already traveled some theta angle anti-clockwise. Theta dot velocity, theta double dot acceleration, so it is further moving. Now from here only, tell me what torques are acting on this system. Write all the torque, and then we will apply inertia torque. That entire summation will become 0. कैसे लिखेंगे equation? How do you write this equation? Sir, we are having this mg force, we are having this tension T also, but tension T, I don't think that tension T is going to give you any torque. Why? Because it is passing through the axis. Mg, on the other hand, it is going to have some torque. What is the torque of the mg? Sir, mg ka line of motion is this. So from here, mg multiplied by this distance is how much? Almost this, almost equal to arc. So arc ko we can write L theta. So you can write mg into L theta. About this axis, it is clockwise direction mein. So clockwise direction mein you are having mg into L theta. This torque. Any other torque do you have? No torque. Ask D'Alembert bhai, he will come with inertia torque this time, and inertia torque opposite to the acceleration, angular acceleration. You will apply the inertia torque clockwise direction mein. Inertia torque, its value is I theta dot dot. Like we were having mass into acceleration, we are having I into alpha angular acceleration. Everything, this entire summation becomes 0. I theta dot dot plus mg L theta is equal to 0. What is the moment of inertia of this setup? Sir, from here, what is the moment of inertia? L distance we are having just mass m, so ml square. I is ml square. Put the value ml square theta dot dot plus mgl theta is equal to 0. This becomes your equation. That's it. What is the omega n? Sir, omega n is under root. Like earlier we were having something x double dot plus something x is equal to 0. Now we are having something theta double dot plus something theta is equal to 0. Under root, this divided by this कितना हो जाएगा, mgl divided by ml square. Solve करिए, omega n is coming out to be, ml gets cancelled, we are having g by l. Same answer, but in only one line I have got the answers. I hope this is clear to everyone. Torque method is very easy. In all situations where we can see pure rotation, it is advisable to apply torque method. It will be easier. Time you will save some in the examination. Another situation, suppose if we are having a rod whose mass is m, length is l, and I have hinged this here. A uniform rod whose mass is given as m, length is given as l. Can you tell me? First of all, tell me, can I apply torque method here? Sir, we can apply torque method. Why? Because I can see by sitting here that this setup is doing rotation only. If you are not disturbing this setup, it will be here only. So this is the mean position. If you have disturbed this a little bit, what will happen? Sir, I saw this setup was moving like this from here. I am sitting here. When I saw from the mean, it was at some theta angle. It has traveled some theta angle, further moving with some theta dot velocity and theta double dot acceleration, something like this. Write all the torques which you can see. Sir, sitting from here, what are the torques which are acting here? Only weight is going to have some torque. Weight is where? Sir, weight is acting at the midpoint. Uniform rod hai, so weight is at the midpoint. It will move here. Weight is acting like this. This is your mg weight. Weight, where it is acting? Sir, this is L by 2 distance. Midpoint pe weight is going to act. So it will be about the center. Mg into ye distance, how much? L by 2 theta. So mg into L by 2 times theta. Any other torque? Sir, we don't have. Ask D. Lambert bhai. He will come with inertia torque. Opposite to acceleration, I theta double dot. I theta double dot plus mg L by 2 theta is equal to 0. That's it. My answer is done. Now just put the moment of inertia carefully. Carefully. What is the moment of inertia? Moment of inertia of this rod. Sir, कितना होता है? Whatever is the moment of inertia of the rod. Sir, rod का moment of inertia ml square by 12 I have studied. That is about the center of mass. Center of mass के about moment of inertia you have studied. You have to tell about this axis. Parallel L by 2 you are shifting. So parallel axis theorem you have to apply. ml square by 12. This is about the center of mass plus m mass L by 2 distance you are shifting. M, whatever distance you are shifting, m that distance is square. Solve करेंगे. So what you will get? ml square by 12. This is ml square by 4. कितना हो जाएगा? This comes out to be ml square by 3. Put the value. We are having ml square by 3 theta double dot plus mgl by 2 theta is equal to 0. That's your answer. That's your answer. Clear है ये बात. Examination में questions have been asked, है ना? One question, GATE 2012 में they have asked for 2 marks. First of all, just I'm leaving this question as an homework. Tell me in the chats, everyone, what is this question? We are having a rod. A concentrated mass m is attached to the center of a rod of length 2L. Rod ka length is L. L2L is the length. So midpoint where we have some mass m shown in the figure. Rod is kept in horizontal equilibrium position by a spring of stiffness K. Okay, ठीक है, this is stiffness K. For very small amplitude of vibration, neglecting the weight of the rod and a spring, the undamped natural frequency of the system is how much? They are asking, tell me what is the undamped natural frequency, omega n. They are asking, can you apply torque method? How we can apply torque method? Sir, from this I center. This is the setup. If you will disturb, it will have this kind of vibration. So from this setup, can I talk about torque method? Try करिएगा. I want everyone to try this question. And tomorrow when we will meet, we will talk about natural vibrations को solve करने का another method, which is energy method. And there are some beautiful variety of the question like this. I will also discuss energy method. Using that, you can also solve these kind of questions. Okay? So I'm leaving these two questions as of now for your homework. Try solving these. Tomorrow sharp at 8 we are going to start, and we will see what is the energy method, what is the relay method, and then we will also talk about damped vibration. Okay? I hope everybody is crystal clear till this point. This is my Telegram group. You can join this group and you can stay connected with me for your all gate theory of machine related doubts. Okay? If you have any doubts which are unanswered in this live chat, live session, you can drop your comments in the comment box. Once the video is over, I will check those comments, and next session I will try to clear those. If in the comments also I'll be active. If it can be answered in the comments, I will reply you. Okay? So let's stop here. Tomorrow sharp 8 we are going to meet. Till that time, thank you, bacho. Goodbye. Love you all.